Alrighty, so last topic for this unit, we're going to talk about domain of composite functions. So I have a few functions defined for you up at the top of page 23, and I just want to do a quick refresher of what it is we're doing when we take a look at composite functions. So I've got f of x, g of x, and h of x there. My first couple of problems are just asking me to evaluate. So for this first one here, g of 4, remember we always work from the inside out. G of 4 would mean I take g of x and I plug in 4. So this would be the square root of 4 minus 3, which would be the square root of 1, and the square root of 1 is 1. I'm not done yet. I still have to evaluate at f. I am taking f of 1. Remember, for composite functions, the output of the first function is the input for the second. So f of 1. So this would be 2 times 1 plus 3, which would be 5. So f of g of 4 is 5. Second problem, same idea. So this is a good little refresher for us. F of negative 2 means I am plugging in negative 2 for x in my function f of x. So this would be 2 times negative 2 plus 3. So that's negative 4 plus 3, which is negative 1. Now I'm going to plug that into h. So h of negative 1 would be 2, and then my exponent is negative 1 plus 1. So that's 2 to the 0, and what is 2 to the 0? 1. So h of f of negative 2 is 1. And then for our last one here, we're not evaluating, we're just giving that composite function. So we're going to take f of x, we're not plugging anything in for x, we're going to take f of x exactly as it is, and use it as the input in g of x. That means we're going to replace x with this stuff. So that would be the square root of 2x plus 3 minus 3. And then we clean up anything that we can. So this would be under my roots, those are gone. This would just be the square root of 2x. Can't simplify any more than that. I could write it as 2x to the 1/2 power, I guess, if I wanted to, but there's not really a reason to do that at this point. So we will just leave it as the square root of 2x. Okay, composite functions. We remember these? Okay. So if I want to find the domain of a composite function, we need to consider two things. First, I need to consider what is acceptable for the domain of my inner function. So for example, if I take g of f of x, I need to think about what is the domain of f of x. If it can't be in the domain of f, it can't be in the domain of the composite. Okay? Does that seem reasonable? Okay. The other thing I need to think about is the domain of g. If it can't be in the domain of g, I'm going to have a problem for the domain of my composite function as well. Here's where things get a little more complicated. Here's where things get a little weird, okay? The domain of g is not values I'm plugging in for x. The domain of g is whatever I get from the output of f of x, right? For a composite function, okay, the output for the first function is the input for the next. So what we need to keep an eye on for g, for our outer function, are the values that we are getting as output values for the inner function. So what we'll have to do is sort of retroactively sort of figure out what x values would give me those output values in the first function that I can't use in the input of the second function, okay? That was a whole lot of words I just threw at you. Let's work through some examples and I think it will make some more sense, okay? But here's what I want you to keep in mind. Any x value that results in an output that's not in the domain of the other function is something that we'll have to exclude. So what we're keeping an eye on here is, are there things that we can't have? What do we have to exclude? Okay. So for our first example, I've got f of x and I've got g of x. I want you to notice these are both rational functions, right? I've got x values on the bottom. That means potentially I'm going to have polar asymptotes. So I'm potentially going to have excluded values. Now we are looking at f of g of x. So that means g of x is our inside function. I'm going to start with that inside function. So in g of x, are there any values that I cannot have in the domain? What do I need to exclude? 2/3. X cannot be 2/3. In g of x, x cannot be 2/3. Okay. So right out of the gate, I have to exclude 2/3. And I'm going to just make that note to myself over here. Values to exclude. 2/3. Can't have it. Can't do it. Quick refresher, will I have a whole or an asymptote at 2/3? Asymptote, it's not reducible. That factor is not reducible. So it will be an asymptote. Okay. Now, f of x, also a rational function. So in f of x, do I have any problem values? What would I have to exclude? Yeah, and we're not going to get like super complicated with our little notes off to the side, right? These are just our notes to ourselves. In f of x, x cannot be 1, right? However, I am not going to put 1 in my values to exclude list because 1 would not be the x value I'm worried about. If I plug in 1, if I evaluate at 1 for f of g of x, if I plug in 1 here, that's 3 minus 2, okay? For this particular problem, 3 minus 2 would be 1. So that would be 4 over 1, right? So if I plug in 1, I get 4. And then if I continue, 4 minus 1 on the bottom is not 0. So actually, x can be 1 for our domain for our composite function. 1, an x value of 1 is not a problem. What I'm looking for is when would this, for what value of x would this be equal to 1? That's the issue. If this whole thing equals 1. Because then when I put it into f, I've got a problem. Does that make sense? Okay. So that's what I'm going to look for. I've got 4 over 3x minus 2, and I want to know when does this equal 1, okay? So I'm going to solve for x here. I am dividing by the thing with x, so I'm going to multiply both sides by that. If in your brain it makes more sense to think of this as cross multiplying, you can think of it that way too. You would get 4 equals 3x minus 2, same idea. And then let's get x by itself. So that would be 6 equals 3x. Divide both sides by 3. And we get 2 for x. So what I'm saying here is that if I plug in 2 for x, g of x would be equal to 1. Let's check that. So that would be 4 over 3 times 2 minus 2. That'd be 4 over 4. And that is 1. So if I did f of g of 2, when I plug it into g, I get 1. Then when I go plug that into f, I would have 5 over 1 minus 1, which would be undefined. So 2 is the problem. Does that make sense? 2 is the problem here. X equals 1, not a problem. It's 2 that's the problem because I need to know what makes that first function equal to 1. So I also need to exclude 2. So when I go to write my domain, everything is okay except 2/3 and 2. So my domain would be negative infinity to 2/3, 2/3 to 2, and then 2 to infinity. So this is going to be our deal for today. For that inside function, we're going to see what values x cannot be. For the outside function, we're going to see what we need to figure out the output cannot be and work our way back to the input value we cannot have. Let's take a look at our next example. Still f of g of x. I think everything I gave you for today is f of g. Pretty sure f of g. Yeah. So all f of g's for today. Here's f of x and then g of x. So let's start with the inside function. Okay. Start with g of x. So in g of x, these are just my notes off to the side. In g of x, are there any restrictions on my domain here? Any values that x cannot be? I have to watch out for some positive numbers, right? Are there any positive numbers that are okay? 1 would be okay. Up to 3, right? Up to 3, right? And including 3. So for here, we could do anything up to 3, nothing greater than 3. So x must be less than or equal to 3. Less than or equal to 3. How about in f of x? Do I need to put any restrictions on the domain for f of x? Do I have any problems there? Square root of x plus 2? Mm-hmm. Any numbers less than -2? Yeah, x needs to be greater than or equal to -2. -2 is okay. We can take the square root of 0. But anything less than or equal to -2 would be a problem. Okay. So what we would be thinking about would be values where the output for g of x would be less than or equal to -2. So when would the square root of 3 minus x be, well, it would go here, right? I need it to be greater than or equal to -2. Before we do anything, I want you to stop for just a second, put your pencil down, and think about this. We're talking in the real numbers. A square root being greater than a negative number. I want square root things, something under a square root, something happens under that root. I take a square root and I get bigger than -2. Mm-hmm. It's always going to be greater than or equal to 0, right? So anything I get out of here has to be bigger than or equal to 0, right? Anything. Because I've already placed restrictions on this domain so that my output will always be greater than or equal to 0. Right? It's not possible that I get down to -2. So it's not possible that I could ever even get -3 or -10 or -100, right? It's not possible I would ever get a value that would cause me problems for f of x. So this, I don't even need to worry about. I already take care of it when I restrict that domain for g of x. Or when I consider, I should say, that domain for g of x. This is a weird one. Does that make sense? I can't ever get negative. It's always going to be 0 or bigger. So really the only thing I need to worry about for the domain by default is what's okay for g of x. So my domain here would be x values less than or equal to 3. If you want to write this in interval notation, that would be -infinity up to 3. Let's take a look at the next one. Find the domain of f of g of x for my functions here. F of x is a rational function, g of x is a square root function. Most of the functions I'm giving you are something where we've got issues with the domain. If it was just a, like, let's say f of x was maybe 2x plus 3 and g of x was 2 to the x plus 1, The domain on an exponential we know is all real numbers. The domain on a polynomial we know is all real numbers. So if I had something where the domain of each is all real numbers, your domain of the composite is just all real numbers. So you might be noticing that we're seeing a lot of functions where the domain is not all real numbers. We have square roots, we have rational functions, stuff where I've got to be careful with the domain. That's intentional, okay? If I've got stuff where the domain is all real numbers for both pieces, the domain is just all real numbers. Let's take a look at example 3 here. Again, domain of f of g of x. So g of x is our inside function. So in g of x, do a comma there. In g of x, what would be my domain? What would be, the x needs to be what? This g of x, square root of x plus 4. Greater than or equal to negative 4. Yep. X needs to be greater than or equal to negative 4. What about in f of x? Rational function, am I undefined anywhere for f of x? X cannot be 2. Let's take a look here, because we had a tricky one on our last problem. Is 2 a possibility out of here? Could I have a square root of something that equals 2? Yes, I could, right? If x is what, right? That's the part I have to figure out now. It's possible to get this to equal 2. It's not a negative number, so it's possible that my square root is equal 2. So what I have to figure out now is what would make g of x equal to 2? What would make g of x equal to 2? So I'm going to solve this guy for x. Square both sides to get rid of that square root. And we're left with x plus 4 equals 4. Get x by itself by moving that 4 to the other side. And we get x to be 0. So in my list of things that cause a problem, I've got anything that's less than negative 4. X has to be greater than or equal to negative 4. And I also will have x cannot be 0, because that would make this be 2, which would make this be undefined. Okay? It's not a bad idea to go back and double check your work. So if I plug in 0 here, that would be the square root of 0 plus 4, which is the square root of 4, which is 2. And then if I did f of g of 2, right? Or f of g of 0, I should say. If I plug in 2 here, that's 1 over 2 minus 2, which is undefined. Okay? Always a good idea, again, to double check your values. So when I go to write the domain now, I need to keep x greater than or equal to negative 4, but it can't be 0. So this would look like, I'm going to write this one in interval notation. Negative 4 up to 0. We can do a bracket at negative 4 because we can have negative 4. That's okay. Parenthesis at 0. And then anything greater than 0 would be fine. 0 to infinity. Questions for me for today? Domain of composites. Okay. Your practice problems are the bottom of page 24. Take your time. Be careful with your work. And I suggest you check your values, right? If I go through and decide that x can't be 0 based on f of x, go back, plug it in, check it.